This is Sanjeev Prakash and my registration number is 18PWE1010, and here I am here to explain about the artificial neural networks. So basically, what is artificial neural networks? So let us consider the neurons of the brain, and they are connected widely and differently. So the same way the artificial neural networks are. The artificial neural networks are just like the neurons of the brain, and they are connected, and this is the basic equipment of the machine learning. So, what is basically artificial neural network? Neural networks are connecting systems which is very similar to the biological neuron activity of the human brain. It is an algorithm, rather a framework of machine learning that helps collect multiple inputs and help in solving complex data. So, basically it's an algorithm and the basic technique of machine learning. So in machine learning you input many complex data. For the resolution and solving the complex data we need artificial neural networks. So just like the neurons of the brain, even in the brain we see many objects, we hear many objects, we speak many things, and it must be stored in our brain. So it's basically the activity that we use in the artificial neural networks. So it's a method of computing based on the interaction of multiple connected processing elements. So it has very simple principles, and very complex data can be easily transformed into simple data. So and this neural networks was created by Warren McCulloch and Walter Pitts. Main idea is to focus on artificial intelligence that depend upon the robots and robotics. So there are many types of artificial neural networks. So the first one is the feed-forward artificial neural network. So this neural network is going to be the simplest form of the neural network, where the data and input travels in only one direction. The data passes through the input nodes and exits on the output nodes. So this neural network may or may not have the hidden layers that actually every neural network has some layers hidden in it, so which makes processing easier. So, but this layer may or may not have hidden layers. So it has a front propagated wave and no back propagation by use a classifying activation function usually. So this feedback neural network, how it basically works is as, because when the output is always feeded back to the input. So this is the main principle of feedback neural network. And the radial basis function neural network. The radial basis function considers the distance of a point with respect to the center. So radial basic functions have two layers. First, where the features are combined with the radial basic function in the inner layer, and then the output of these features are taken into considerations while computing the same output in the next time step, which is basically a memory. So it basically considers the center of the point from that is the distance of a point with respect to the center, and this is how radial basis function neural network. So coherent self-organizing neural network. The objective of a coherent map is to input vectors of arbitrary dimension to discrete map comprised of neurons. So this is basically a vector operation of the neural networks. And the next is the recurrent neural network, that is the RNN, long short-term memory. The recurrent neural network works on the principle of saving the output of a layer and feeding this back to the input to help in predicting the outcome. So it also uses the principle of feedback, where you give the output as your feedback of the input. And same way, the output data is used here as the input. And next is the convolution neural network. Convolutional neural networks are similar to the feed-forward neural networks, where the neurons have learnable weights and biases. Its applicable have been signal and image processing. So it's usually used in digital signal processing and image processing. And last is the modular neural network, and have a collection of different networks working independently and contributing towards the output. Each neural network has a set of inputs which are unique compared to the other networks constructing and performing subtasks. So many systems or workstations work on the basis of the neural network. So this is the reference here given below, and thank you.
Hi guys, myself Kapuluru Shravya. I am going to explain a topic called artificial neural network. What's meant by artificial neural network? An artificial neural network is an attempt to stimulate the network of neurons that make up a human brain so that the computer will be able to learn things and make decisions in a human-like manner. Artificial neural networks are created by programming regular computers to behave as though they are interconnected brain cells. An artificial neural network is an information processing model that is inspired by the way biological nervous systems such as the brain process information. They are loosely modeled after the neural structure of the cerebral cortex but on much smaller scales. In simpler terms, it is a simple mathematical model of the brain which is used to process non-linear relationships between inputs and outputs in parallel like a human brain does every second. What are artificial neural networks used for? Artificial neural networks are used for a variety of tasks. A popular uses for classification. For example, of different breeds of dogs. Train a neural network on the images. Then if you supply a new image of a dog, it will give a statistical score on how closely the new image matches the model and then will output what breed of dog the image is. Neural networks are also used in self-driving cars, character recognition, image compensation, stock market prediction, and lots of other interesting applications. As we have neurons and synapses in our brain, we have nodes and weights in artificial neural network. Nodes are same as neurons and weights are same as synapses. The normal artificial neural network. The neuron receives n inputs, multiplies each input by its weight, applies activation function to the sum of the results, and it gives the output results. Feed-forward network. Information flows through a neural network in two different ways. When the model is learning and when the model is operating normally. When the model is learning or operating normally, patterns of information from the dataset are being fed into the network via the neural input neurons, which trigger the layers of hidden neurons, and this in turn arrive at the output neurons. This is called a feed-forward network. Input, hidden, output, and the balls are called as nodes and the lines are called as weights. Types of activation functions. There are three types of activation functions: sigmoid or logistic, tanh hyperbolic tangent, and ReLU rectified linear units. At present we are using ReLU rectified linear units, as sigmoid and tanh hyperbolic tangent are having their own disadvantages. Sigmoid activation function. It is the activation function of form f of x equals to 1 by 1 plus exponential of minus x. It is a S-shaped curve, and this input will be lying 0 to 1, and it has major disadvantages. It will fall vanishing gradient problem. Second, its output is in zero centered. It makes the gradient appears go too far in different directions. This is the graph of the sigmoid function. It's hyperbolic tangent function, tan h. Its mathematical formula is f of x equals to 1 by exponential of minus 2x, 1 by 1 plus exponential of minus 2x. Now its output is zero centered because its output lies between minus 1 to 1. It also same as sigmoid function. It also falls under vanishing gradient problem. This is the graph of hyperbolic tangent function. Now we'll see the problem of feedback data to the net. As input, hidden, output are given, and then the nodes of input, and we have to find the hidden, and the weights are also being given. Now it's like 1 into 0.25 plus 0.5 into 1 minus 1.5 will give the hidden value. Thank you.
Hi everyone, so I am here to talk about our IIP project. We have done it based on the topic AN and artificial neural networks. The basic concept is it was inspired from biological neurons. Biological neurons are a complicated network present in our human brain. They take in all the complicated information and give us a simplified output. There are almost like 2 lakh neurons in the human brain. They take all those complicated inputs and they give out a simple output so that the brain can act so fast and easily. So in the same way, artificial neurons are like they can take in all the complicated information and they simplify it and gives us a simplified output. Like if we want to solve a complicated problem, we give a various complicated inputs or feed it into it, and through various processes it gives a very simple output which can be easily solved. So here we are going to see about the types of artificial networks we are going to use, like training and different types of training used in artificial neural networks. There are 3 types. First one is supervised training, second is unsupervised, and the third is reinforcement training. So if we see in supervised training, all the input and the desired output is basically fed in, so the process is going to take place based on the output we need to give. The system goes through the various different process based on the desired output that is going to come. Like both the input and output are known to the system, and based on that it is calculated. The set of data which enables the training is called as training set over here. And in unsupervised training, there is no help gathered from outside. Only the input is fed in and no desired output is given to it. So it goes through various trial and error methods to find the desired output. It is also known as adaptive training. In reinforcement training, it is about taking suitable action to give a maximized reward in a particular situation. So reinforcement training differs from supervised training in the way that no desired output is given to the reinforcement learning. Like the answer key is not provided, so it must act accordingly. It goes through various processes to get the desired output. it is bound to learn from its experience. And applications we have since ANN can take in a lot of complicated information and give out a simplified output. It is mainly used in image processing. Various complicated information is fed to it, and then easily it is able to give a character recognition. And it is also used in forecasting, in business predictions. It is very useful to businessmen, and it gives about the sales factors, etc. Character recognition in the same way, it use feed forward networks to recognize various characters in a straightforward pattern. Medicinal purposes, it is used in calculating the data of heart rate, blood pressure, breathing rate, etc. Security, it is very importantly used in security due to its complicated input and easily giving output nature. It is used for various security reasons. And yeah, that's it.
Hi guys, this is Vishwath. My group members have been presenting on this topic. My part is to do with applications of neural network, but let me brush through the whole concept and then go to the application. Okay, let's get started. Neural networks. What does a neural convey? Neural word convey? Something related to neurons, right? Yeah. Neurons is the most fundamental particle, most fundamental part which helps in processing of data in brain. We tried, so the brain has the powerful capability of solving any kind of situations we have. We tend to take decisions, right? So we are trying to duplicate of the brain by doing its function artificially. So that's why the term artificial neural network arises. Let me tell you a story of pigeon which inspired human to create something like artificial neural network. Yeah, this is called something as brain box. It captures the images from our mind from capturing the brain waves. So this is a pigeon. This is not a normal pigeon. This is a dove. You know what this dove used as in the previous days? It's used to convey messages through the long distances. Okay. How does it actually do? Let us say this dove passes through a terrain, a river, and a crowded place to reach a destination. It needs to deliver its message. So while doing it regularly, it captures the image like this. This is the river through which it passes through it, and this is the crowded place. It goes through it. So every time it encounters this particular situation, it compares this image with what it sees. So this is called image processing in modern term. It processes this image, compares it with what it sees, and then proceeds to its destination. That's amazing, right? Okay. This is what is image processing in simpler terms. Okay. Now, after before going to the artificial neural networks, there's a necessity of activation function. What is activation function actually? Yeah, this is activation function. Let me tell you why the activation function need. Let us say you have a sensor to sense the humidity. you are getting digital signals as an output from the sensor. These signals will be in terms of like lakhs, maybe in thousands, or maybe in hundreds. No one knows. Okay, let us take it gives an output in thousands. To deal with this kind of large data, we need a large storage. So in order to reduce this particular problem, we use activation functions. When we feed the data into the activation function, let's say like if we 1000 into the activation function, it gives the output as the 0 to 1. It has a range. This function has a range of 0 to 1. So this particular function is a sigmoid function, 1 by 1 plus e power minus x. Let us plot this sigmoid function. The function is 1 by 1 plus e power minus x. So how does the graph of this function will look like? Let us plot. How to start proceeding? Let's take the value or boundary values. For x is 0, it takes function takes, let's take this f of x, and f of x is 0 is 1 by 2, right? When x is infinity, the function becomes 1 by 1 plus e power minus infinity. E power minus infinity is 1 is 0, sorry for, then the function value becomes 1. So this is a point, this is 0.5, and this is a point, this is 1, somewhere like this coming. For let's take for f of minus infinity, sorry, for x is equal to minus infinity, f of minus infinity is equal to 1 by 1 plus e power infinity. This is something like 1 by 1 plus infinity. 1 by 1 plus infinity is 1 by infinity. That is equal to f of infinity is equal to 1 by infinity. That tends to be 0. So this function is 0 on the when x tends to be minus infinity. So this is a function. This is a sigmoid function. That's explained in this part. Okay, this is a sigmoid function. We plot a sigmoid function. Now how does this function actually works? F of x is equal to 1 by 1 plus e power minus infinity, e power minus x, sorry. Let's take we are giving a value of x is 4.7. So f of 4.7 is equal to 1 by 1 plus e power minus 4.7. Value of this function, it tends to be like 0.98. So we are feeding a number greater than 1 and getting a number lesser than 1. We'll always get a number 0 to 1. So this is an advantage of the activation function. We can handle data easier with this. So I have demonstrated an example on how the activation function actually works. Let's move on to the next topic. Feeding the data through net. It's actually so simple. You have two values. One is a value of the node and another one is a value of synapses. Multiply both of them and add various the multiplied products, like first node has a value 1 and the synapses has 0.25. Multiply it and add it with the 0.5 into minus 1.5. That is the node 2 and the synapses 2. Now we'll get a resulting value. Feed the resulting value to the activation function, and the result we get is is the value of the node, which is the question mark over there. So this is how the value is calculated and assigned to each particular nodes. So we get an input through the output. We feed the input and get output by this method. Types of neural networks. Basically it can be classified into three types. Three particular topics. Connection type, it can be classified as static and dynamic. Topology type, single layer, multi-layer, recurrent. And learning methods, supervised, unsupervised, reinforcement. I'm not going into the types as it's been explained by Sanjeev. I will go to the applications of the neural networks. Voice recognition. Voice recognition uses neural network. Before demonstrating you the example, I will tell you how it actually works. Okay, let us first now see how the speech is being processed theoretically. The voice the receiver takes is considered as speech. After that, the method is speech pre-processing. In that method, we will ignore the noises which the receiver captures along with the speech, and the feature extraction. This feature extraction technique is important here. What does it actually do? What does it actually do? This feature extraction extracts a particular feature, like a voice. Let's say the example, the input is hello. This word can be pronounced as hello and also hello. So the different modulations of it extracts the specific features of the word, of a particular word, and stores it. Speech classification. Now the speech classification is a fundamental thing in the voice recognition. It classifies each input as data and stores it. So when the receiver receives a speech, it converts into data and compares it with the previously trained data. So if it matches, let's say it matches the data RAM, it shows our recognition speech as this voice has been recognized as RAM. So that's how the voice recognition actually works. Let me demonstrate an example for you. So let us practically work out how the neural networks acts as a voice recognition. Let's take two examples. There are two persons, there are two voices, Steve and David. We are having a data of these two members. We are giving an input of 60 bins. That means the primary part of the neural networks has a 60 pin input format. Yeah, I'm basically talking about this part. This has 60 input pins. We have two output pins here, over here. Two output pins. If the output is 0 and 1, then it's Steve, and the output is 1 and 0, then it's David. Let's train the network like that. So we are giving an input over here, we are getting an output. So how this is actually calculated? We have seen previously how the data are calculated and assigned to the nodes. I'm again saying if the input over here is 0 and here it is 1, then it is Steve. If the output is over here is 1 and output over here is 0, then it's David. Over. That's our code. We are feeding a waveform over here in the 60-bin format. That means 60 inputs. After calculating each node, we have assigned the output. We got the output as 0.43 and 0.26 and 0.73 and 0.55. This is actually untrained network. So we are feeding the data and we are getting the output. So we should get an output of 0 over here and 1 over here for it to be Steve. Zero over here and 1 over here for it to be Steve. So what's the error? We are calculating the error. Subtract it, magnitude of the error, add it. This is the error. So we are getting an error of 1.17 in case of Steve and error of 0.82 in case of David. So we are back propagating the error and modulating the synapses value according to that. So change in a synapses value you can get a desired output, right? So we are changing the value of synapses in such a way that for Steve it should give an output of 0 and 1, and for the David it should give the output of 1 and 0. So we have an error of 1.17 here. We are back propagating it, changing the synapses value. So while multiplying it, automatically the data should be changed. Changing the synapses value will give us a desired output. How does this work when it's trained? So we are feeding multiple data in order to train this network. This is the graph we plot. Okay, repeat process multiple times. That's the only key method for this. Train the data as far as possible to reduce the error. Let's zoom it. This is a graph we got. This is a total of like 1 million data has been fed, so that the error is tending to be 0, but not 0 exactly. That's the problem. So we have to train the network as many times as possible to reduce the error. So what we have done actually, calculate the data, feed the data, calculate the error, back propagate the error, adjust the weights. So this is a trained network. Now we are getting a value close to 0 at the first node and close to 1 at the second node. This is what happens. So it automatically, this machine understands that this voice is Steve's and this voice is David. If the output is 1 and 0, then it should be David, or close to 1 and 0, 0.99. So this is how voice recognition works. Interesting, right? Okay. Advantages of neural network. As it replicates our brain, it has so many advantages. It can solve many real life situations like we solved. So that's all for our group, guys. Hope you liked our group presentation. Like and subscribe it. So as a conclusion, I need to tell that neural networks provide an ability to provide more like human-like artificial intelligence. It takes a rough approximation of hardcore reactions of artificial intelligence. Still require a lot of fine-tuning and during the development of it. The thing is, you have to train the data. train the machine with the data in order to get a particular correct output. So preferences. So any questions, please comment below. Thank you.